BlindEye, we believe we can stop crime before it happens, and that everyone should have access to smarter home security. You may already be familiar with the recent boom in interest around home surveillance. Startup companies such as Ring have already infiltrated the market of a whole home protection and become spearheads of private surveillance systems today. Yet, in spite of this apparent tech success story, we believe the concept is underdeveloped. And in a billion-dollar industry growing at a rate of over 20% per annum, there is space to fill, and so much development and benefits for homeowners yet to be realized.
We present BlindEye, the completely novel application of image detection, facial recognition, and machine learning, which takes all of the hard work and communicates to homeowners intelligently. Our BlindEye system applies models with massive image banks and learning algorithms to capture footage from around and inside your home in real time, and grows to understand who are familiar faces and regular visitors at your property, and distinguishes them from possible trespassers.
BlindEye then automatically reviews footage through its constantly updating detection algorithm. BlindEye can then communicate its findings to its users in a digestible manner. If there is deemed a possible security worry or entrance breach attempt, a user will be pinged in real time via a mobile device, whether through an app on their phone or otherwise. Users can then review recorded footage with our identification tags or can receive updates in an audio manner.
BlindEye saves time in your day too. It's easy to set up and pair with pre-existing surveillance cameras around the house. Users will no longer have to drop what they're doing manually to review surveillance footage, drastically reducing the potential risk of triggering false alarms or wasting your time manually reviewing footage of a cat that's jumped over your window sill.
There's a BlindEye plan for every home. We offer a basic plan that activates video recording and image processing and audio representation for one device with limited cloud storage. Our premium BlindEye Plus offers a more comprehensive plan that activates this service for all devices at your home and grants an unlimited cloud allocation for familiar face storage. We are currently expressing interest in being a necessary extension to Google's Nest, Amazon's Ring and Alexa, and Uber. BlindEye is in the running for receiving grants and incentives from the government's NDIS program, who will support the installation of our product.
Current industry giants have systems that can work well. They also fail in their simplicity and have contracted a reputation for tripping false alarms. Generally, these home security systems primarily detect using IR cameras to determine the presence of a large and warm intruder. Inside the home, Ring alarms come with pet-friendly motion detectors that should ignore animals in the home up to about 22 kilograms. However, this is not compatible to homeowners with larger pets or your escaped infant who decides to leave the crib in the middle of the night. There's countless backlog of false alarm claims from consumers against services currently offered. Incorrect callouts for police assistance incurs a substantial fine in many countries for an unaware neighbor or resident in danger of being arrested.
Following this, many users have opted out of their subscriptions in fear of these totally avoidable false alarms. Ring's protocol, for example, contacts emergency services on your behalf should it detect a possible threat and you not be near your phone for manual review. To us at BlindEye, it appears peace of mind is a crucial determinant for consumers, and that this is preferred over protective systems that are successful sometimes. Of course, all of these detection models completely ignore the existence of the blind. In fact, there are so few alternatives inclusive of this 285 million person worldwide market. The space largely sits ignored. Above being unfortunate, this is also largely inconsiderate. Those without sight are especially vulnerable against the threat of burglary. It makes little sense that they should be disallowed access to interactive home security measures.
Of the two makeshift solutions that seem vaguely inclusive, both are rudimentary and only work to detect objects such as large cars in the direction that they head. They can alert their blind users with either piecing audio alarms or solid and infrequent announcements.
It's clear to us at BlindEye, interference of a blind person's auditory sense can be extremely disconcerting and aggravating at times, and as such, visually impaired persons are especially sensitive to an audio alarm. Another service provides 24/7 monitoring of a blind person's home, Service works by involving proctors, essentially removing independence from the blind entirely. Even then, a proctor can miss reviewing one of their screens when it matters, or can call police to the house without the knowledge of the homeowner. This poses obvious privacy concerns, with constant footage being projected to unnamed staff who are often operating abroad.
Both of these services further disclude the blind from involvement in their own home security and limit the understanding of the surroundings with intrusive sound alerts. These are not effective solutions, as they essentially arrest the development of the blind from forming true independence in their sense of security within the home. We have made a better alternative. Let's take a look at BlindEye's prototype form. Our system interprets your live surveillance footage, reviews it for potential flags, such as human, and communicates this information in a manner that is customizable and will make it digestible for all users. Our system allows its users to make informed decisions and hence remove unnecessary stress to an already stressful occurrence.
Foreign human detected. BlindEye fine-tunes how existing home security and surveillance is applied and expands its access and user base to the visually impaired, who have, until now, been excluded from actively engaging in this entire category of protecting themselves and their homes. At BlindEye, we think everyone should be afforded the ability to protect themselves, and this time we mean everyone. BlindEye, keep real crime out and peace of mind within.
All right, yeah, that's our presentation.
Very nice. Thanks for that. I think that was a very slick video. I hope there's time for at least one question.
Can I quickly ask a question, because I will have to park the car if you.
Go for it.
So very nice video. We want to know what you actually implemented in the 48 hours of the hackathon, and how does that work?
Okay, Ashwin, do you want to cover that? Seeing as
Yeah, so basically what we made was like a basic prototype. So the surveillance camera basically is constantly like watching and basically looks for changes in movement, so it can detect humans. So if there's a change in if it can detect movement, then it causes an alarm to go off. And
what algorithm you use for detecting the movement?
Sorry?
What algorithm are you using for detecting the movement?
Also, we basically use this segmentation algorithm. So it looks for changes from the previous frame. So if it sees that there's so we use a HSV segmentation. So if it detects a change, then it causes a audio sound to go off, which alerts the blind user.
So Liesl here, is there any differentiation between just regular human turning up at your doorstep or someone behaving suspiciously? And also what about pets and animals wandering around?
Yeah, that's the whole point of the product. So that's where we were headed. We spent most of our time coming up and fleshing out the idea and figuring out how we could make this saleable before we invested all of our time into actually coding this product, unfortunately. So we didn't get incredibly far in that actual process, but our vision is totally there to be able to distinguish between faces, to be able to tell between what is a familiar face, what is a postman that comes every week, and then what is a completely foreign face, what is a dog, what is a bird, what is a ball. That is our vision.
And did you consider any potential ethical implications around keeping databases of people's recognized faces around?
I consider it to be more of a good thing, actually. And although we weren't able to explain entirely everything we had come up with in 7 minutes, I think it could be extremely ethical on the flip side, in that it can help identify repeat offenders and then also triangulate their positions really in a neighborhood. And I think that could help a lot more people out, and that would do a lot more good than people's worries about data privacy.
That's really dangerous ground. Rob here. Hi, guys. Yeah, so you got to be very careful about your assumptions around doing good there. The unintended side effects of this technology are significant. The other question I have, the core tech you're talking about is already implemented in several competitive categories around the detection of individuals, object classes, different types of, animals, pets, postmen, whatever, known individuals, etc. The question I have to you is, what specifically do you think is innovative or in your approach for your use case?
For our case, we're taking a product that we found to be extremely popular and taken over by Amazon, which is Ring. And we found a product market that's entirely been left out of the ballpark, really. And so we wanted to allow our system to firstly be specific to those who were hearing impaired. Not hearing impaired, we're blind. So our system was originally considered to be something that could verbally communicate and interpret what is being seen and deliver that to someone who is unable to see it. So therefore they can feel some sense of independence and understanding of what is going on in their house. So that's the differentiator for us.
All right.
I'm Harrison, and I'm joined here today with Liam and Zach. We're here by mistake, and welcome to our solution. So just quickly, an introduction to the our response to the brief. The brief said that we needed to use image processing or computer vision to enable accessibility and provide social benefit specifically to those with disabilities. So we specifically decided to use computer vision to approach problems within the COVID educational space, and are specifically targeting those with learning difficulties. So here's a quick map of our decision-making process. We came up with like 3 primary ideas: enhanced glasses, Engagement Plus, and sign language reader. And we decided to go with Engagement Plus because we strongly resonate with the problem and we identify and understood the target market. So a quick overview of our problem statement, which we analyzed by looking into the 2 pillars of our target audience, students with disabilities and teachers. So meet Sarah. She's a 15-year-old high school student with Down syndrome and ADHD. She enjoys learning, but struggles to stay on task and requires help from the school's additional support mechanisms. The shift to online learning following the pandemic has rocked Sarah's educational experience, and she's felt left behind without the additional support she requires. More importantly, she's lost the human connection she thinks is essential to keep her motivated and on task. Unfortunately, Sarah is not alone, with all students' education suffering throughout the course of COVID-19. Secondly, we'd like you to meet Ashley, a primary school teacher of 10 plus years. She's also feeling the impact of the shift to the learning environment as she struggles to interact with her class in the same way she's used to. Ashley feels demotivated by online learning and is particularly frustrated she's unable to communicate with her students and gauge their participation or engagement in class. This is particularly essential for students she knows regularly fall behind and require a bit more assistance to remain on task. So our situation is that the coronavirus has impacted the conventional methods of education. A switch to online teaching has left behind learning difficulty students, and we believe that a good solution is to target these students and build a more cohesive learning environment. So welcome to our solution, Engagement Plus. Our mission is to enhance student-teacher connection to allow for better class engagement through the implementation of computer vision and behavioral therapy, and user-centric design which integrates with pre-existing educational tools to allow for easy use. Moreover, our company vision aligns with the visions of Zoom, Microsoft, and Google to allow for easy integration into the pre-existing educational sphere.
Introducing Engagement Plus. So by enhancing our current educational tools, we can enhance this teacher-student connectivity. So as you can see here, the general idea is that from the teacher's point of view, other student screens will go slightly redder as they get, I guess, more off task. And it's 5 tiered. So it starts out here where it's opaque white, and then it gets slightly less opaque reddish and less opaque reddish until it will be bright red. And that is based off time. So 3 minutes of being off task, and it will go to the next tier, whereas 20 seconds of clearly being concentrated will bring it back a tier. So we're calling it our weighted involvement score, the algorithm, where it incorporates face, body, and eyes. The face recognizer will be looking at emotion, particularly confusion, distress, or anxiety, as well as general concentration. The body focuses on positioning of the body, such as facing the camera, as well as actions like leaning back on your chair, which sounds a bit like it's more behavioral, but it's more like, you know, if you're leaning back on your chair and looking away, you're clearly not concentrating. Then the eyes, we use a similar eye gaze tracker to what's used in like advertising to gather user metrics, and generally see if they're looking at the computer, as well as hopefully further down the track, seeing if they're following the cursor of the teacher. Obviously, there's many edge cases that we have thought of, but it's impossible to include it all. So our product, we developed through a process with many challenges. We decided to scratch the Raspberry Pi because our ARDA didn't really require it. As we were so pushed for time, we decided to go for a box machine learning model instead of creating our own. And we tried many frameworks, starting out with OpenCV and Python, and then moving through to using TensorFlow with the React front end. So we tried a WebGazer API, which uses hoe circles. Didn't really work particularly well, and all the really good eye gazing stuff is all closed source. And then we tried PoseNet for body positioning, which uses heat maps and offset vectors. The issue is it requires you to be able to see your full body, which, as you can see over Zoom, isn't really an option. We essentially tried every TensorFlow model under the sun, and probably should have just stuck with one, to be honest. Probably experimented a bit too much. The Zoom API sucks, so we couldn't integrate it into Zoom at the moment. And we had many errors, and we also just, we kind of screwed around a bit with Netlify and Heroku to try and see if we could put it live for you guys. Ultimately, we haven't produced what we set out to produce. However, using JavaScript, HTML, FaceAPI.js, and Netlify, we've created a taster that you guys can try it yourselves. Might send into the chat and you guys can maybe try it later because we're running a bit low on time. But yeah, if you're on your phone, it won't work. You have to be on a laptop and it takes like 5 to 10 seconds to load. But it's in the chat in like a few seconds time. This is our roadmap. So this is what we're up to now. We're wanting to implement other things such as a sidebar, which is this kind of idea. So it's easier to keep on track, as well as various other features like image to closed captions recognition. Over to Zach for our financial strategy.
All right, so just for the final minute or so, the financial strategy that we had mainly focuses on 3 areas: the production, the target market, and the scalability of our product. We're very blessed that our idea has very low variable costs, with the only cost mainly being the very small labor costs of software engineers and customer service employees, as well as server costs. Our target market currently is very wide. Over 500 million students are still currently learning online, and this is roughly a third of all students worldwide. And also, our target market will always exist. It's a permanent factor in society. And our scalability, the variable costs for the service are very easily scalable. We can change them daily as needed by the number of users that we have. Our business model takes into account 2 things: the amount of users at the school and how many platforms they want to be able to use. The 3 platforms that we're planning to offer are Zoom, Google Classrooms, and Microsoft Teams. The average school size is 525 students. We round that up to about 600 if we include teachers. So as you can see, these prices are monthly, and registered special schools have a 20% discount on top of this, in line with our business vision. Our strategic timeline and future predictions: it'll take us 1.25 years to break even. We need 3% market share.
Wait, Liam, you're gonna have to cut it short just about here, so finish up.
Yeah, that's yeah.
You can finish off reading that slide.
We're predicting 100K plus profit by the end of the 3rd year, and a 64% growth in profit over 5 years.
Cheers.
Thank you.
Can I jump in? I have a technical question, which I'm probably going to hand to Greg after I start, because I'm pretty sure Greg's probably going to jump on the same thing. How do you guys delineate between someone with Down syndrome and different facial behaviors, different thresholds for attention and interest against a standard group of students? How do you actually deal with that issue? Because obviously
those were some of the many edge cases that we were talking about. So it isn't really like an all-in-one offering. It's something which, you know, if we were to produce it, it would have to be quite customizable.
It would have to be individually suited to the demographic of the class. Like, the other thing that we had to consider was different age groups as well. So we were thinking that, you know, a younger group, particularly primary school students, is going to be different to maybe university students or high school students. So pretty much a lot of the design.
Really? No, that's pretty much the same. The lack of dent is pretty universal.
Well, yeah. So we thought that the design process is going to basically have to be customized based on the demographics of the class.
I want to jump in and ask a question because I'm pulled over to ask this. It's Lisa here from McKin. I want to first congratulate you on the rigor you put into the process, identifying and analyzing the need. It was quite well-rounded where you went all the way to how you're going to take this to market and revenue model. 2 comments or questions though. The one is, I would question if you've done enough, and I know 48 hours is not a lot of time, but if you've done enough from the ground up of thinking about usability and what is the experience like for the end user. It's been a long time since I've been a teacher, but from my experience, telling someone with ADHD flashing that they're not paying enough attention may actually have a counterweight effect to what you're after. So I think the question was, did you bake in any time at all to actually speak to people who'd use this product? I recognize that it's not easy to find someone with Down syndrome at the drop of a hat, but I think if you went into any Sydney suburb and throw a handful of rice, you'd hit someone with ADHD. Second question, I think you've vastly underestimated the costs of initial product setup. So people with disabilities typically, particularly if they're intellectual disabilities, will struggle to onboard and get product set up and used in the first place. So I think your cost of initial setup and adoption would be a lot higher than you anticipate. So I just wanted to ask or comment on those 2 things.
Well, I guess I'll jump on the first question. So I've actually been teaching a young boy with autism and ADHD over the past 6 months. And we actually reached out to him in the creation of this product. And I agree that the red flashing light system is could lead to is slightly distracting. But what it is more of a banded system so that they have something to focus on. And it's not on the student. And it's not on the student's screen. So the red flash was for the teachers so that they can reach out, kind of identify students that are distracted, reach out to them individually and perhaps lend some sort of additional assistance or try and pull their attention back to class through maybe a supportive question or kind of just like pointing out that perhaps they need to pay a little bit more attention depending on the situation. Again, this will be up to the teacher's discretion and will be kind of an individual thing. We don't want to tell teachers that a red screen means that they need to discipline a child or anything like that.
So basically you're helping the teacher's cognitive load where they're trying to, in a very primate way, figure out who needs support and who doesn't, and you're reducing their cognitive loads. That's a good thing. Thank you.
So good morning, everyone. Our acronym for our project is OSIAT, which stands for Object Saving, Identification, and Tracking. Before I get into our prototype, let me talk about our target market. Our target market are elderly adults with memory impairments. Family and caregivers of those with short-term memory loss are also gonna find our prototype useful. Due to increasing age, biologically, several impairments arise in older people. Age-related memory loss is one such impact. A study in 2017 alone identified that 15% of Australia's population were over the age of 65, and this number is expected to grow. Dementia is one of the neurodegenerative diseases caused by Alzheimer's. It deteriorates brain functions, induces memory loss, and disrupts abstract thinking. Dementia affects a great population of Australians. In the year 2017 alone, the Australian health system had a total direct annual cost of $9.1 billion. This really gives us a scale of the impact of dementia. As such, paid carers, informal carers play a critical role for people with dementia. The impact of this insidious disease is so great that it affects not only people with dementia, their carers, their families, the health and aged care systems, the Australian economy as a whole. While engineers and health experts aim at mitigating the impacts of dementia as far as possible, our particular solution for the hackathon aims at targeting the impact of memory loss from these impairments. Memory loss can be extremely pervasive and can disrupt daily activities like work, hobbies, social activities, and family relationships. So let's first look at some of the existing technology that can improve the lives of those with memory impairments.
So assistive technologies like smart gloves and smart home systems use voice commands to perform tasks like calls, simple web searches, playing music, and many more. There are also smart, wait, is it, there are also smart watches and phones that can act as assistive timers for day-to-day activities like appointments, search duration, and others. In terms of misplacing items and for finding devices, provisions like Find My iPhone, GPS trackers, and Bluetooth trackers ping devices to further find them. An interesting invention is the Tyler tracker that you can see on the right. There are cheaper versions available too, but our question is, how practical Bluetooth trackers like this are for the daily lifestyles of our elderly. We found several differences with Bluetooth trackers like the tile tracker. The cost of each sticker tile is at least $27 US, with a major issue being that you have to buy and stick on the tracker sticker for every single item. Our technology aims at removing this inconvenience. The stickers also have other impracticalities, such as difficulty sticking to items such as nail clippers, glasses, and socks, just to name a few, and present the potential choking risk for pets and children if the sticker falls off.
Yeah, so our system is aiming to increase the accessibility of elderly adults who suffer from memory impairment and to tackle the impacts of memory loss. So in terms of the usage of the system, the user will add the items that they wish to track by taking a photo of them. This then adds them to the database. Then our technology will use computer vision to identify the tracked objects that are in view while the device is working and saves their location when they're in view. So if a user believes that they've lost an item, the system will help them to track the item by sending them to the most recent location that object was seen. So if I screen share now, I can demonstrate just a simple a user interface that we've got to just demonstrate how it'll work. So first off, it asks what item that you'd like to track. So this is like taking a photo of it at the start. So if I add keys, phone, and wallet, and now it's outputting, this is just for reference, it's outputting the user's location and then outputting the locations of all the items that are being tracked, as well as if they're visible or lost. So now I'm going to go to the next frame. So that's the next frame of the video input. And we're just incrementing the location by 1 every single time, just for demonstration. So now we can see that the phone is visible and its location has been updated. So now we go to the next frame and the location keeps updating. And eventually the phone is marked as lost. So now that the users realize that the phone is lost, they then say, I found there's a lost item. What item is lost? They'll input that the phone is lost. So this could simply be just a touching of a phone icon or entering the text of phone. So it tells you first that the phone is lost to check your pockets and bag, because obviously those aren't visible to the computer, to the computer vision. Otherwise, it's giving the location of that it was last seen. So once it's been found, you say, yes, it's found. If we go to the next frame, we can see that the phone is now not lost. So now I'll pass over to Joel and he'll demonstrate the feature detection version.
So our current system uses feature detection to try and identify objects that we have taken photos of and that we wish to track. So first of all, we've got 2 images we're currently tracking in the system. We've got the bamboo box is the one I'm showing, and the previous one was the Raspberry Pi box, just as examples. So once he hits enter, it'll show a feed of a video where we are trying to identify these objects. And if you click on the command line interface on the right, yep, you'll see that it is telling us which frame it is currently on, and it also shows us the last time that each object was identified. So this is using feature detection, and if we wanted to improve this, we could use a combination of feature detection and also video filtering and segmentation.
Thank you very much, team. Your time is up.
Did I see that the user has to wear a clip? What's that for?
The clip is for the camera to be put on. So the camera will be here, so it gives the field of view of the user.
Would it make sense to have a camera in the environment instead?
Potentially, but then the computer vision will be a bit more complicated because the user's location would have to be tracked in the room, and you need to have a camera in each individual room. Whereas if the camera is on the person, then it's seeing what they're seeing, so it knows when when the object was last seen.
One more from me. I sometimes lose my stuff. Do I need Alzheimer's to buy your product?
No, you don't. Anybody can buy our product.
Excellent.
Yeah, quick question. It sounds like you guys are relying on when to tell you where. So when the location of an object disappeared, how do you correlate or get good information back to the user as to where the lost item is?
So the idea that we were going to do is using an IMU system just to constantly try and figure out the location of the device. We didn't get around to producing that or being able to actually develop that sort of system. But if we were to properly produce this to put in a market situation, we would be able to track the device itself.
So my assumption here is that the device would be on the person, always on, and providing some sort of dead reckoning around the locations when an object went out of frame.
Yes.
So a user could backtrack.
Yes.
So the location of the object is saved as the location of the user. So it's not using any depth perception in the actual video feed. It's just.
That's understood. Yeah.
Cool.
Unless you're someone like Greg, who throws his stuff when he doesn't want it anymore, there might be somewhat of a difficulty. Anyway, thanks.
All right, thank you very much, team.
So our product is called Emo-Buddy. It's camera-based technology that helps people with autism spectrum disorder better handle social interactions. So firstly, the team includes of myself. I was mainly in charge of the product design. Ricardo was mainly in charge of software, and John was mainly in charge of hardware. So the general problem was that when we were first introduced the brief in the opening ceremony, my first thought came to my little cousin who has autism spectrum disorder, mainly the fact that he really struggles with social interaction. And since the hackathon was based on computer vision, we decided to focus our attention on nonverbal communication, specifically facial expressions. And many studies show there's a clear struggle for those with autism to be empathetic, especially to understand visual cues that people who are typically developed would consider an emotional expression. So our first thought was, well, what are the current solutions and how can we make them better? So as of now, the only real solutions to this issue generally revolves around teaching. So role-playing, observing others, and professional teaching. This could be either personalized or group-based. But there are also some other ways to deal with this, including games and audio or visual prompts. So when we saw visual prompts, clearly this is a vision-based hackathon, so our light bulbs went off. Generally, people with autism have little flashcards or little boards with pictures on them. And instead of trying to explain a situation, sometimes they tend to just point to the picture because it's much easier to communicate that. So looking at these solutions, we thought, well, what can we change? How can we make them better? And what we found was a lot of these solutions are so great in the long term, but right now, children with autism are left behind until the teaching is finished. So until the 5-6 years of therapy has worked out, these children are still unable to socially interact well. Games and visual prompts do help with this short-term goal, but they're only effective inside the home and inside spaces of comfort, like let's say a therapy center. So once these kids are brought to the outside world, this doesn't really help as much. So what we tried to think of was a way that we could provide a product that could be used in outside spaces of comfort and essentially use these visual prompts but integrate it with vision-based technology. And when we thought about the available vision technology, we started just at the most basic form. We know that cameras and computers can recognize humans. But this isn't enough for a real solution. So thinking a bit more, we realized that we could start recognizing faces, which is great because now we have some form of handling social interaction. But still, we needed a bit more. So we decided to resort to emotional recognition. So after a bit of research, we realized that there are neural networks out there that can recognize simple emotions like happy, sad, angry, surprised, disgusted, and fearful. And this is exactly what we needed, because those with autism spectrum disorder really struggle to even harness these simple emotions.
Okay, so to introduce the Emo-Buddy, the device is a child-friendly solution which uses vision-based technology and visual prompts to assist children with autism. It helps these children to focus on a single person in a social situation and helps them understand and interpret facial expressions. The Emo-Buddy has two main features. The first one is its ability to identify all people in a social interaction and then only focus on the closest person. This helps the autistic children stay focused in social interactions and ensures that they don't feel overwhelmed. As you can see in the video, although there are two people in view, only the primary person is focused on. The second feature is its ability to interpret the emotions of a person in focus and visually display the emotion on the device's screen. The Emo-Buddy is capable of interpreting neutral, happy, sad, angry, and surprised emotions. As you can see on the right, the device interprets any of the four emotions and distinguishes them from a neutral face, assisting in the autistic child's ability to interpret emotion and improve their social ability. So how does the device work? Firstly, OpenCV's built-in facial recognition features are used to detect all faces and focus on the largest face in view. Next, a pre-trained emotion identifying neural network is used on the face to determine which emotion they are using. The pre-trained model initially had the disgusted and fearful emotions. However, these are not primary emotions in social interactions and were hence removed to improve the accuracy of the device. A custom handler is also used to detect when the neural network is certain about a particular emotion and filters out any noise or flickering in the predictions. Finally, the predicted emotion is shown on the visual display.
So in terms of its marketability for the current prototype, it's the only product of its type. There really is no emotional recognition products outside of just Git repositories and APIs. There's nothing really that regular people could use. And unlike other solutions for people with autism spectrum disorder, this product is integrated directly into the individual's life and social environment. Whereas, like I said before, other methods are at home or at the therapy center. Furthermore, we're able to customize the visual prompts. So in our video demonstration, the visual prompt was an emoji. But if a child isn't comfortable with emojis, we can easily change that to help individualize the product. Furthermore, there's very minimal components, so it's reasonably affordable. And it also fits very well with the social struggles that children with autism face, because people with autism tend to avoid eye contact. So this product would help them remain socially involved because they're not staring at the person, rather they're staring at a screen. In terms of scalability and future marketability, so moving from a prototype to a product, we thought we could design custom cases to help it make the product more durable and more comfortable to use. So if we're thinking about autism, children with autism, we could possibly make a case that looks like a monkey or a giraffe, something that they're really comfortable with using. Furthermore, we could improve the hardware and software to increase speed and efficiency. So designing our own mini PC to prioritize RAM, because the Raspberry Pi was quite laggy and delayed, or buying a camera with higher frames per second and using techniques like threading.
Your time has now concluded.
Okay, well, just right in. This is the license for the neural network we used. Yeah, thank you for listening, guys.
Maybe as a way to lead on from what you were just saying, what technical innovation is missing before you can bring this to market?
Sorry, say that again.
What technical innovation is missing before you could bring this to market? So what problems are remaining?
So we found with our prototype, the biggest problems were trying to make it small yet efficient. So on my laptop, it would work perfectly because my laptop's got great processing power. The Raspberry Pi's got very small RAM. So trying to make a concise design was the biggest technical innovation we faced. Furthermore, we didn't, because of the time frame, couldn't really look into design aspects that would be comfortable for people with disabilities to use. But yeah.
Thank you, guys. Very nice presentation and on the spot answer. Actually, I think the idea, we saw it, everyone in Big Bang Theory, right? Howard built was such a system for Sheldon, if you remember. I don't know if you follow this comedy, but just a quick question regarding the evaluation of the solution that you have. Did you actually try to evaluate and see how is the performance of the solution that you proposed?
In terms of using
false
it?
positive, false negative.
So
How
do you mean
good the recognition is?
Oh, okay. So so these videos are used on the actual Raspberry Pi. When used on the laptop, it works perfectly fine. But on the, especially because we removed the disgusted and fearful emotions, but on the Raspberry Pi, due to the efficiency issues, we could only get, like, let's say 2 frames per second, because the camera we were given only had around 8 frames per second initially. So on 2 frames per second, it was very hard to get a reasonably working model. Furthermore, the neural network we used was based off of image data sets, a data set full of images, whereas our technology is using video. So that was another hurdle we had to face. Yeah.
Thank you.
Thank you.
Perfect. Thank you very much.
No
Sorry.
more questions.
Yeah.
We have to move on, do we?
I guess we can fit in one just like really quick question.
Yeah, I wanted to ask 2 things. One about form factor. Social isolation is a huge issue, as you've highlighted. But if someone's sitting around pointing cameras at people, it might actually increase social isolation and eccentricity. So I was wondering if you were thinking about a brooch or some other form factor that makes it less obtrusive. Secondly, I wanted to ask if you're considering other markets besides autism. I think, as I recall, 1 in 150 people in Australia live with autism spectrum disorder, but about 1 in 100 live with schizophrenia, which, they suffer similar issues around social recognition of social and emotional cues. So form factor and adjacent markets are my questions.
Yeah, so in terms of adjacent markets, I believe we could easily integrate into those markets, but we definitely have to consider the issue of comfortability, because different people are comfortable with different things. So those with autism are definitely uncomfortable with eye contact, but I myself aren't too versed in schizophrenia. In terms of the form factor, we did think about, for future, how could we make it a bit easier? So there's always the option of smart glasses, but at the end of the day, some people don't like wearing smart glasses. It's not too comfortable, especially in our case, we believe that people with autism wouldn't want to have something dangling on their head, rather a toy to play with. So there's always this compromise between the comfortability of the child and the comfortability of the people they're interacting with. But we decided to prioritize the child in this case.
Yeah. You guys got to go. I just want to say great job, and look at a Snapdragon 865 chipset, modern smartphone. Go straight there.
Thank you so much.
The sound doesn't seem to be working.
466 million people worldwide who suffer from deafness, and they are forced to face the challenges that come with this on a daily basis. Their relationships with family and friends often suffer when people don't have the time or money to invest in courses to learn sign language, and online alternatives often fall short due to a lack of interactivity. When going to see a doctor, lawyer, or any consultation expert without an interpreter, it can be difficult to fully communicate and receive sufficient treatment and consultation. This is only exacerbated by the Auslan interpreter shortage that Australia has faced for years, meaning that in critical situations, deaf people aren't getting the cares they deserve. Furthermore, the assistant principal for hearing support in Coffs Harbour said about deaf refugees, they are mostly languageless, with no previous amplification or form of sign language. We need to teach them Auslan through pictures first, then sign, then fingerspelling, then written word. These issues share a common root, a lack of awareness, appreciation, and avenues for learning Auslan.
We want to approach these problems by providing a platform for both the languageless and for those who already know a written language to learn sign language whilst getting real-time feedback on their signing using computer vision. This language learning app will utilize different learning paths for different target groups to help them learn sign language. By lowering the barrier of entry for people to learn, we can give the languageless, the deaf, and their family, friends, and colleagues an easy avenue of communication. No other online resource can grade you based on the quality of your signing, and considering how high the barrier of entry is for an in-person class, we think this is extremely important, especially during COVID, to bring this to an online space. Introducing Signed.
Here's the landing page that users will see when they open our app. We've designed this to be as simple and accessible as possible for everyone, avoiding words and leveraging visual cues to allow for accessibility for languageless users. Down the bottom, we have our app's mascot, Steve the Squid, the signing teacher for enhanced visual education. It's important to provide a fun and welcoming platform for users of all ages. And by having a mascot, we hope that users, particularly young users, will be more excited by and engaged in the learning experience. Here in the Pictures module, users will be able to learn in their chosen sign language using pictures that are associated with a hand signal. For example, that's cheese, and an image detailing how to perform the sign will be displayed on the screen. The button on the bottom of the screen will then bring up the camera for users to practice the sign and get feedback using a combination of machine learning and computer vision. We will demonstrate this more in detail in the next section of our app, as the neural network has not yet been trained for words yet. Here in the text-based module, users with a better understanding of a spoken language can learn sign language using words and letters. In our current model, we've been mostly integrated with the American Sign Language System for English letters. Similarly to the picture-based module, the button on the bottom will bring up a camera to test your knowledge. The user puts their hand in the marked region of interest, and the program continuously samples that region and passes it into our neural network. The neural network will utilize a pre-trained VGG16 network that has been specialized on a dataset of ASL letters. The neural network returns its prediction for the letter expressed in the image, which we compare to the target letter and provide feedback on the clarity of the signal.
While the technology that Signed uses is still maturing, there is great scope for development of our platform to a worldwide audience. Given more time for training, as well as access to a wider range of training data, this product could be used to assist learning in any sign language and thereby reduce the barriers of communication between people with all levels of hearing. Additionally, the capability of the system, currently limited to identifying letters, can be increased to allow for phrases, as well as utilizing facial expressions to allow users to develop their own personal style, instead of rigidly adhering to an impersonal framework like most systems encourage today. The potential for Signed to grow and disrupt the market for sign language education is something we're excited to lead. It's a genuine solution that addresses a clear need for our society. It's a highly viable and profitable application, as seen with other language platforms, which can support an income through ads and in-app purchases. It can be easily available on both phones and computers, and it only requires a minimum initial investment for maximum reach across Australia and other markets. Watch this space for the future of sign language education.
Awesome. All right. Okay, that's about it. So we are now open to any questions from the judges. And I'll stop sharing.
Could you just quickly clarify the use cases? So you demonstrated recognizing if a sign was correct or not. Can I show it a piece of cheese and have it show me the correct sign for cheese?
No, it wouldn't be able to do that. It can recognize your current sign and tell you whether that's correct or not based on what it's learned, but it can't recognize images.
We haven't trained it using any like full words or phrases like cheese. But we have sort of got it working with the letters.
Though, would the plan be to be able to show it objects and have it give you prompts?
I guess if we developed a neural network that was strong enough, then that would naturally come out of it. But right now it's supposed to just be an education platform, not a translation platform. Yeah, because I think it could definitely slow down the recognition of the signing if it's also trying to check whether it's an image as well, like if it's trying to check if it's any objects. And I don't know if we'd be able to get a comprehensive enough library to make it viable, but like long term, that would definitely be a good goal.
And is there any existing sign recognition software out there that this could leverage?
Yeah, so that was part of the idea actually. So there are a lot of networks that are trained on things like ASL, Auslan, the various sign languages out there that exist. And so our platform is generic enough that it can use any neural network that's pre-trained, whatever. You can train it with your own data set. And it can be very easily adapted to different languages, or as you were saying, like we could increase its capability to identify objects and provide the signs for that to enhance the learning ability.
Cool, thanks.
So just to make clear, do you mean that you're going to use the same model? When I'm saying the same model, the same neural network to recognize sign language and to recognize objects and translate them into the sign language? Okay.
No, it'd have to be a different network. That's right. Yeah.
Okay.
Real quick question. Can it detect motion? I know a lot of the signs are actually differentiated by motion rather than the configuration of the digits, for example.
Yeah.
That was something that we did struggle with initially when we started preparing this, but we found that in testing the neural network, it has been able to recognize J so far, because like I is just this, and then J is the same, but then moving down. And it was able to tell the difference between them somewhat, but I think with more training, it could definitely be trained to recognize motion. Yes. Yes.
Perfect. So if there are no further questions from the judges, we'd be happy to let you guys go. Robert, do you have any final questions for Team Signed Vault Dwellers? No? All right, perfect. Thank you very much, Team Vault Dwellers. An amazing solution so far, and we're looking forward to seeing what you guys do with it. Thanks so much.
Thanks, guys. See ya.
Right, so hello, my name's Dennis. Cindy, Daniel, and Nathan are our team. So so the goal for this challenge was to create something that would benefit society or individuals using OpenCV. And so, based on that kind of design brief, we naturally thought of doing something for visually impaired people, kind of a natural thing to do. And so we did a bit of preliminary research and found that I think like the majority of like legally blind people are not completely blind. They still have some form of useful vision. So we decided to kind of narrow down the problem scope and target that particular audience. So we kind of narrowed it down to, how can we improve the well-being and independence of someone with a mild vision impairment. All right, Nathan and
So in our market research, to first understand the problem, we had to look into the type of people who are affected by the vision impairments. And because vision impairment isn't just a single issue, it's affecting multiple different types of people in a different manner. So this vision impairment can be measured by two core methods. So visual acuity, which is the distance in which a person can see clearly, as well as their visual field, or the amount of peripheral vision that they have. Around 80% of these people over the age of 50 have visual impairment, which is with around 10% of these people suffering from either age-related macular degeneration or cataracts. The symptom of these issues are a difficulty seeing in low light vision, as well as low vision acuity and difficulty in recognizing distant objects or small text. Given this, we chose to target people who had limited ability to see but were not completely blind, as there was a greater opportunity to provide help with new and emerging technology. Given this, we will be able to alleviate symptoms of these visual impairments during the And then we also conducted market research on existing solutions. So these existing solutions included a stationary magnifier, which is placed on a table to magnify nearby objects, as well as a simple visual aid for reading more text. The problems with these solutions are that they're really large and highly not portable, such as the stationary magnifier, and they're often extremely expensive, ranging from $200 to what you can see $2,000 for just a simple camera and screen to magnify. They also have limited functionality in their ability to read text and decipher objects and condition the image.
So what is our solution? Our solution to this problem was that we wanted to design a portable device that would be truly portable. Now, what Nathan just talked about in the slide before, those devices were considered portable and it costed $2 grand. And it's actually just a monitor which needs external display and needs external power to power display. We wanted to design something that was truly portable and would actually help users have easier access to the information around them through text. Right, so we want to improve the interpretability of text. And by utilizing modern technology, we can create these portable devices to improve upon the existing solutions and fix the problems that used to be fixed in a better way. So what have we done? Our system has these core features. We're using computer vision. We're making it portable. It's independently powered. It's got a built-in display, so it doesn't need an external monitor with external powers. And we're providing some quality of life features to be dynamic in any situation. So those include adjusting image qualities such as brightness, contrast, and zoom. And the zoom can be just digital or physical, depending on what hardware we end up with. The core functionality of our system, however, is to be able to detect computer-generated text within images and do these kind of translations and put it on top of a screen for users to see in a much clearer way. So we've chosen computer-generated text for situations such as street signs, restaurant signs, which are generally fairly rigid and provide very meaningful information to users. Now, what hardware have we gone through? We're using the Raspberry Pi that's provided, and we've also 3D printed a case just to contain everything in a nice compact module to simulate what our final product would look like. Obviously, we're using a camera module to take video input, as well as tactile physical buttons, which are easier for visually impaired people to interact with rather than having to navigate a screen like a touch screen, touching specific locations, which they might struggle with. That said, we also do provide a touchscreen display just because we recognize that they're visually impaired, not completely blind. So these just provide like ease of life functions to shortcuts, per se.
All right, so just about our software pipeline. So one of the main challenges is kind of detecting like where is there actually text in an image, right? Like there are lots of things out there that do OCR, but those work on like there's just text in the image. So you kind of really need to be able to find out what the text is in the image, and to do that we use a neural network for the efficient and accurate scene text detection to find like text in the wild, right? Like just there's only little pieces of text in an image. And so after we have these little like snippets, we use OpenCV to kind of make it, to process it and make it easier for the Tesseract or neural network-based OCR engine to convert it to actual text. And rather than me talking about it, I think it's better to just show a demo of it in action.
Okay, unfortunately, you're going to have to let this software demonstration play during your question time.
Okay.
Yep.
Well, what time are we at?
Yeah, your presentation time is finished.
Okay. Okay.
Apologies.
Maybe run the video while we do Q&A.
Yeah, that would be fine.
And my question is, what does the user experience look like?
Oh, so I think we'd rather show you the hardware demo first for the. So can we come back to that, Don? Because we've got a hardware demonstration as well, which shows the user experience.
You might want to choose to mute the clip while the questions are being asked.
Are you guys able to get this audio?
That was
It's at the bottom of the clip.
So now we'll be doing a demonstration of the hardware that we produced, which uses the software that was just showcased. So what you can see here is a 3D printed case which houses our mock-up of the personal digital assistant. Just showcasing some of the features that we've implemented. What we wanted was to ensure it was portable. So as you can see here, we've got a portable power supply powering this thing. As a mock-up, we're just using a power bank, but in the future, we'll have onboard batteries.
Don, would you like us just to answer it in person? I think the internet's cutting out a bit.
Can be recharged. Additionally, there's a screen which normally acts as visual feed.
Don, can't hear you. Don?
Yeah, so time's up.
Yeah.
Quickly tell how it's often used.
So from the user experience is just, it's got a sort of view, camera-esque behavior where you navigate a viewfinder to where the user wants to see. And based on that, you can take a picture of it, and with like a button you can see on the top left, and that just saves your picture. And from there, we can do additional processing, such as zooming in, and the EAST algorithm finds regions of interest to help users identify where possible signs are. From there, we're allowing users to zoom in on these areas to specify to the algorithm what areas in the screen we actually want to process. Afterwards, we pass it to the OCR, which then produces actual translated, like digitalized text. So that's the user experience.
Imagine if you could only choose between Woolworths and Coles for the rest of your life. No variety stores, no window shopping. That's the unfortunate reality for blind people, because the sad fact is that not every supermarket has the resources to cater for the blind. Now, Smart Company tells me that Coles and Woolworths groups share a whopping 60% of the revenue share in the retail sector, but as a blind person, that's a lot less impressive, because you're missing out on more than 90% of the variety on the market. Think about all the sensations you could get in a modern shopping district. The texture of denim jeans, the smell of fresh coffee, the rich taste of dessert. Kyanometer wants to give blind people the confidence to step out into that world by helping them locate shelves and product in shopping locations that are too small to otherwise cater for blind people. Now, let us show you how it works.
Hi there, my name is Evan, and I'll be doing a live demonstration of Kyanometer's real-time barcode scanning functionalities. This will be conducted through the use of my mobile phone's camera and our web interface, shown here. So, let us begin. As you can see, the video stream showing on the screen right now is taken directly from my mobile device. And basically, when I use the web application I showed earlier, it triggers functionalities for our program to detect barcodes. So when our program detects a barcode, it also triggers an audio cue to tell visually impaired customers information regarding the products they're looking at. So how our program does this is it searches up the program information on a database of barcodes. To test the audio cue, to test the operation of the audio cue, I will now trigger a basic say hello function.
Hello world.
Which you have just heard. This tells us that the audio cues are working.
Hi. Yeah. This is Evan speaking. Sorry, I think the video turned out a little bit soft. So I'll just 200 grams 100 pack. Yeah, I'll just do a quick speak over of what's happening. So right now the video stream was coming from my phone, which I recorded yesterday. And basically whenever we detect a barcode, our program is able to intelligently provide information to a visually impaired customer as to what product they are looking at. And we're gonna do a scan of a few items. So the first thing was a box of Lipton tea. Now I'm gonna do it on a can of Solo, and afterwards there'll be a pack of jumper cables and a Raspberry Pi. And yeah, there'll also be audio cues for those when it detects appropriate product. Yep, so when our program actually detects the barcode, it will also provide a still frame. I'm not sure if you noticed it earlier on, a still frame of the actual
Part of our solution is a shelf price tag detector.
To demonstrate the price tag detection capability, we took some footage of the shelves at Harvey Norman. As you can see, our system is able to detect the price tags as well as the prices. The system uses a number of image processing techniques, including saturation filtering, contour detection, and text detection to achieve this.
The third part of our demonstration will be a product label detector.
Now, in this first scene here, you can see that East is able to easily recognize most of the text within the scene, and Tesseract is able to identify the keywords, Anchor, 74, fan, tower. The next aroma diffuser here is pretty much the same result. However, we were having trouble with repeated words, although it even is able to highlight even the smaller words in the package. Here is the same case with sale, and it recognizes the price as well as other text in the scene. And another aroma diffuser is also able to recognize the small text as well.
So, a quick recap of our product. We have a shelf price detector, a product label reader, and a barcode database, all going through a phone interface. Where our product stands out against other systems is that other products require the stores to enter their products into a database, while our product is much more flexible and adaptable, opening up a whole new range of boutique shops to vision impaired people. The most challenging part of this exercise was making a robust, busy scene number detector. Most number detectors fail on scenes where there are so many different text snippets, but our system is able to overcome this barrier. Aside from that, we've combined a number of other technologies, including ubiquitous phone hardware and text-to-speech to bring you our product. There are also plenty of directions for growth in our processing platform, recognition framework, and product information services that we can make to improve the service offering for our customers, given more time and resources in the future. One final question: how viable is this as a service? Let alone the 285 million people who are visually impaired around the world, there are 500,000 visually impaired in Australia. If 10% of these people use Kyanometer twice a week for shopping, instead of having to call in a $50 NDIS support officer, this brings us $30 million in annual recurring revenue. Ultimately, we are offering the visually impaired access to a whole new world of diversity, and that's worth more than can be put on paper. Today, we are proud to present Kyanometer, bringing flexibility, diversity, and freedom to the in-person retail experience for the visually impaired.
Thank you so much. We'll now open up the floor to any questions.
I have one. First of all, well done. I like how you've done such a well-rounded presentation so quickly. I like that you actually got into stores and got your product working. I think my main question, I've got a comment to make though. I like that you put the size of market, but there was some two glaring challenges with it. The one is that you said per week vocally, but per month was in the slide in front of you, or the other way around. The second is it looks like your assumption was a direct replacement, so $50 support that accretes instantly to $50 in your pocket, which is just not the case. When people are substituting, human for technology, they typically want a much lower cost. So just on your business model, that was glaring. But well done that you did the work in the first place. My question is, where would you go to from an experiential point of view? So when you were doing the barcoding, I'm thinking if you're blind or you're living with blindness and it's COVID and you've got to touch stuff, that would be pretty scary having to find the barcode scanner. So I like that you went to label detection straight away. Is there anywhere else you'd think of going to make this a more qualitatively good experience for someone living with blindness?
Yeah, for our final product, we were actually we didn't get to achieve what we initially set out to. We wanted to make the system like a bit more robust. So if you were to scan an entire shelf, it would see all the labels and it'd figure out like at Kmart, a lot of the products are placed on the same shelf. So if you scan it, you'll see the same word over and over again, and the system's able to filter that out and just say the single word, like a tower fan. So a blind person could like navigate through shelves, hold their phone, and the system will be robust enough to identify items on the shelf and just say like, this is what this is. And that was like, yeah, that was the goal for our item detection. For the barcode detection, we were hoping, yeah, for a bit more of a robust system. Yeah, we didn't actually consider the fact with COVID, which was a good point you brought up. Yeah, the blind person would have to interface with the product.
Okay, good afternoon, everyone on the panel. Today, I'd like to talk about the Shop Mapper, our solution to improving the accessibility of physical retail stores. We are in the midst of a revolution with online giants like Amazon directly competing with physical stores. They attract customers with more product variety and the convenience of home deliveries. This is a problem for smaller businesses as customers will always choose the most convenient option available to them. There are also additional barriers to physical shopping, including physical impairments like mobility and vision. In-store navigation. Imagine getting lost in a Bunnings and not being able to interpret signs. That would not make for a fun time. Finally, the COVID-19 pandemic has hit physical retailers particularly hard. Far too many businesses have been unable to reopen their doors after the lockdown. We believe improving in-store navigation will be the best solution for this dilemma for 3 key reasons. Firstly, improved customer experience. No longer will you have to dread getting lost among the aisles because you couldn't find that item you saw online. Increased accessibility, particularly for those with vision impairments like partial blindness, those who have trouble reading signs, perhaps people who aren't fluent with English, for example. Finally, increased independence. The Shop Mapper will allow individuals to shop without the need to rely on staff assistance or home deliveries. Now, a mixture of solutions to this problem have been implemented worldwide. These include things like more detailed signs, home deliveries, community-based assistance, mobile apps, augmented reality. However, we believe none of these really addresses all 3 points here correctly. This is where the Shop Mapper comes in, an innovative wearable device solution that doubles as a voice-based personal assistant. The Shop Mapper aims to streamline physical shopping by offering navigation and item identification capabilities to help users find the things they want quickly. And now here's just a quick rundown of how the Shop Mapper works, but I'll explain this in more detail shortly. This video demonstration shows how users can interface with the audio and navigation. Again, due to the time constraints and lack of access to hardware, this is all I could come up with. Oh, sorry.
Can you answer some questions in the meantime?
How much time do I have left? Yeah,
You have 3 minutes left.
Okay. Yeah.
What's the storage for the map? What data type you use? Or...
Oh yeah, I'm going to explain that in the next slide. I can skip
you
over.
can use this time to explain actually.
I'll just go on to the next slide. It explains in more detail. Okay, so the first step, so I'll explain how the nav operation works. Firstly, the store's data is preloaded as a package onto the shop mapper. And this includes a detailed floor plan and items database as shown. So this is just a CSV file with and an item database. And the store map can be loaded as a CAD file or a CAD file, for example. Next, the user will be prompted to name an item they want. Queries with the preloaded data can quickly confirm if it's available or not. And using Google's API, we can recognize a range of expressions with the possibility to expand to multiple languages. Next comes the navigation, which can be divided into two problems, localization and providing directions. Localization can be achieved by strategically placing April tags around the store. These images can be processed to provide a relative position in the store. The Apple Indoors Map program can also be integrated. It's Wi-Fi based, and it can be used to provide an absolute position in the store. To provide directions, the shop mapper converts the floor plan to a tree network. This makes it easy to implement algorithms or whatever complexity is necessary to achieve the correct function. The demo I showed you used a very simple one just for the purposes of a working model. But ultimately, the goal is to get to the correct aisle block, shelf, and level. This is the yoga example that was in the demo. Once the shelf is narrowed down, the user needs to pick up the right item. There are several ways to go about this. For our demo, the user was instructed to simply pick up an item from, say, the top shelf, and the shop mapper will verify whether it's correct. To eliminate this trial and error, we could implement more efficient algorithms so that multiple frames in the object can be classified. And finally, when the user gives the indication, the shop mapper provides the navigation to the checkout using the previous navigation and localization methods discussed. So in essence, we hope the shop mapper will change the way people shop by improving the accessibility of physical stores for everyone. Thank you for listening.
Thank you very much, Jason. So if judges have any questions, feel free to ask.
Jason, I don't think you're going broad enough with the way you're thinking about your problem space. So most of your competitors is trying to zero on a little thing and do it well. What you're demonstrating here is the ability to think across modalities, across problems, across mediums, and that's pretty rare. And I know you're gunning at this, doing this all on your own. I think you are sort of stuck between, having to do both execution and a broader vision here, and we get that. So I'd encourage you to look broader vision.
Yeah.
I actually had a similar feedback. You really were thinking that shopping is not just about walking out the door and putting something in your shopping bag to take it home. It's about the experience, which gets lost when you're blind. And I think I also want to ask, where would you take this if you had more time? What would you be doing?
Firstly, I'll start by implementing the computer vision aspect of it. And let's see what else. If I had more time, I probably would have, as I mentioned in the slides, talk about multi-language support and I'm just like Robert said, trying to broaden the target user base to more than just people with vision impairments, looking at people who are struggling with the English language, for example.
I just want to add a tiny bit of feedback. I know everyone says the demo is worth 1,000 words, but anyone who's ever taken a live working product out to sell it for the first time knows that it will inevitably fail. So a good thing to do is capture an image or a video of your product working. And then if you get time at the end, then run the live demo. Make it clear that this is live. It's not just a doctored video, but what it does is it focuses the audience's attention on what you're doing, not on a demo that's hanging, which could just be an internet problem or whatever. So just a little tip from someone who's been on the road for a long time.
Oh, right. Yeah, I'll remember that for next time. Thank you.
Unfortunately, this is the end of your time, Jason. Thank you so much. Well done, Herculean effort on your own. So that deserves some recognition. Thank you so much, Jason.
Thanks for having me, guys.
Okay, cool. So onboarding of visually impaired employees introduces a range of challenges, and this is both for organizations and the employee themselves. So often humans use visual cues to differentiate between co-workers as they get to know them. So becoming comfortable in a workplace becomes an increasingly large challenge for visually impaired people as they have to navigate the space without knowing everybody and where they sit in the organization. So on top of this, Australia has the lowest full-time employment rate for visually impaired people, and this is one of the challenges that we wanted to solve. So we introduced our solution to help visually impaired people navigate the workspace, identify who their co-workers are and what their role in the organization is to allow them to get used to working there and meet new people.
Right, for our project scope, we focus on getting the employment rate of visually impaired people up. To implement our solution, we are reaching out to social organisations such as Vision Australia, Disability Employment Australia, and Blind Citizens Australia to facilitate the training of staff and also integrating it into businesses. The cost of the product should be affordable, such that any visually impaired person can afford the product, and the processing side can be offloaded to a scalable phone app, so that we have a hardware, we just have a camera for the hardware, and then we can have all the processes on a phone.
So the proposed solution. So we have to use computer vision to facilitate these workplace conversation and friendships by making using the facial recognition when those with visual impairments are around their co-workers. The system would identify, say, the face ID for each co-worker, and these face IDs would be backed up on a central database very securely, just in the business's database. So yeah, there's a face ID for each co-worker, and then the corresponding the relevant notification would be sent to the visually impaired person's device and spoken aloud using text to speech. This can improve the communication for the community by notifying who's around the visually impaired employee during work and conferences, so they can better sense the work environment. And yes, with appropriate training and education, this will improve employability outcomes. But why? Oh.
Widely available Bluetooth microphones and cameras, so it can be easily for manufacturing, as like we have some new technologies such as computer vision and AI technology to improve the facial recognition and machine learning stuff. Also for the price, like since like the most price will cost on the Raspberry and the cameras, so it's around $150, so it can be adopted for use like on a mobile phone and smart glasses. And like we have a potential needs for the blind community, like in every year over 66,000 people who are blind or experiencing significant visual issues. So like the solution will help the employment by reducing inconvenience of those who are visually impairments in the workplace, and improve the communication between those who have visual impairments and others. Like after that, like the pressure for this community will be reduced, and they can build confidence in the networking. As a result, like the social participation for this community will be improved, and some team building will happen.
Okay, so our minimum viable product was just a Raspberry Pi as a front-end client device, which was attached with a Raspberry Pi camera. So this just records the facial images and transacts with a server, and then after getting a response of who the face is identified as using employee ID. Then text-to-speech is used just to alert the user the name of the detected coworker and their distance from the device. We managed to put that in the MVP as well. Now, the server just uses machine learning, specifically SVC, of the image data against, and this was trained using employee faces that would be put on by, say, the HR department of the business. And this is securely sent, the relevant employee information is just securely sent back to the client to be read out. Now let's have a look. Yeah, the video.
Let's see.
A setup and the server computer receiving the requests. For example, detecting someone. Blue is detecting this is an example.
0.47 meters away.
So that's 0.47. You can see our setup there as well. All right. Okay. And here's our references. And thanks for watching. And we'll have any Q&As. Just keep in mind with the prototype that the video we don't actually need the video. That was just to show. And so that's why that's really slow. The Raspberry Pi can't handle that.
I think the spooky ghost voice is, I think you wouldn't call that a bug, you call it a feature. Just roll with it. It's pretty cool. So I have questions. So there's a number of market issues. This is very much in my wheelhouse, what you guys are working on. So I'll give you a few pointers. So think about the broader applicability of your solution. I get that there's probably privacy constraints that put you down the road of looking at an employee-based location and secure data access and stuff like that. There are other solutions that can make this a broader solution in the market. I think it's great that you're actually looking at this problem because it is really intimidating as a blind person. If you're fortunate enough to get a job, because there's 70% unemployment for the blind, it's a big leap. The other consideration, just to throw at you guys, is the number 2 concern, aside from just general fear about spatial mobility for the blind, is being treated as another. So as a blind person, you are likely very much in a minority, or probably the only blind person in the workplace. You are by default going to be treated as a novelty and as another. So anything that accentuates this otherness is generally a downside. So consider the form factor of your device or approach, and consider how it would be used to facilitate, what would feel like quote unquote normal social interaction to actually help level the social playing field for the blind individual. But generally good work, guys.
Thank you. And thanks for eating into your break. We really appreciate it.
And
Perfect.
I just have a general tip, having raised tens of millions of dollars into various tech businesses over decades. General rule of thumb, 1 slide for 1 minute, one idea on each slide. You've just got to have discipline around that. People don't want to process a lot of information. So just a tip going forward.
Yeah, humans are lazy.
Yeah, avoid redundancy. That's one of my comments. There was a lot of redundancy in the slides.
Also avoid redundancy.
And redundancy.
And redundancy.
And redundancy.
I think they've got the point. Go.
Next slide, please.
Oh, yeah.
A man on a Yahoo forum posted his experience with his blind colleague. When he went over to visit to discuss a paper that they were co-writing, he noticed that the lights were still on. Although some blind people leave their lights on to prevent an intruder from breaking and entering, upon asking his colleague, it turns out he had no idea that his house had been illuminated for days on end. His sister had visited over a week ago to drop off some of her cooking for those with acquired tastes. She must have been the one who had left the lights on. Excusable. Light switches, especially ones not in your own home, is something that hardly ever crosses your mind. His colleague had gone early to bed that night with a headache and had completely forgotten to check his switch positions. His kitchen light would have been on even during the day, and none of his neighbors had been thoughtful enough to come by and let him know.
According to an epidemiology conducted in 2017, approximately 1.4 million children in the world are blind of various degrees. This could be caused by various vision impairment conditions, such as pediatric glaucomas, where the intraocular pressure increases stretching the eye and splitting the membranes of the cornea, optic nerve hyperplasia, which is the underdevelopment of the optic nerve, which prevents visuals being received by the brain, or Leber's congenital amaurosis, which is the impairment of the development of the retina, resulting in incorrect light perception. These children are more likely to be socioeconomically disadvantaged and require frequent visits to the hospital. It had also been observed that there is a high prevalence of comorbidity amongst blind children, including intellectual disabilities and the autism spectrum disorder.
Those born with blindness often have to find alternative methods to complete day-to-day tasks. Unlike you and I, these people do not need to turn a light on when they entered a room, so it's pretty easy for them to forget that the light is on when their guests leave. Events such as the one aforementioned should never have to happen and are a completely unnecessary consumption of power. Just in the last year, 6,196 petajoules of energy was recorded to have been used by Australians. Especially with the steady rise of Australia's energy usage, we should really consider how much of that value could be prevented by actively reducing electricity use and energy-conscious designs.
Yep, so our solution for this demographic is to create an automatic light switch system, appropriately named the invisible light switch. This system uses deep learning, whereby a camera sensor connected to Raspberry Pi uses facial recognition software and matching to detect people moving in and out of the house as they come in through the door. Our product will only be able to identify the congenitally blind member, whilst everyone else will be classified as random people to be counted if they are inside the house. A proximity alarm will also be used alongside the light switch so that when the lights are turned off, the camera sensor can conserve power by also turning off. If the door is opened, the proximity alarm will reactivate the camera to scan for random faces. When there is no one or only the blind person inside, the camera will hold on to a signature timer for an hour to ensure the lights are not needed and then will be turned off.
The lights can be switched off by using smart light bulbs, which are more compact, brighter, and have better color representation and can be easily connected to the Wi-Fi network, and then turned on or off by our product. The slide shows a representation of what the camera will be, showing when somebody is leaving the house. The red box indicates the recognition of a person within the frame of the camera sensor. By connecting this to the fuse box in a house, the solution can then turn on and off the lights when needed.
Our project stands out from its competitors since the conscious design accounts for the redundancy in indoor lighting and a niche target market. Unlike most other designs, energy efficiency is essential for a long-term environmentally friendly solution. Although the invisible light switch doesn't come with voice activation, it instead uses facial recognition and motion sensors to detect whether the blind individual is home alone. This opens up opportunities for extensions, such as person-specific security systems, which will further benefit the user and their family.
So funding and marketing will be done through partnerships with organizations such as Vision Australia. Their support can help us expose our product to our target market, who can then greatly benefit from our design by reducing unnecessary electricity bills whilst collectively reducing our carbon footprint. Working alongside other brands with a similar goal to improve the quality of life of those living with vision impairments opens up opportunities for collaborative design so that we can reach a wider audience. Crowdfunding as a method of funding the startup of this initiative can simultaneously advertise the product to the public and create awareness for the people living with disability community. We will target this broad demographic as advocates of those living with blindness and other disabilities, hopefully inspiring inclusive and understanding workspaces and communities.
The timeline of our product after development is to first launch the invisible light switch to Australian users. We will provide assistance with the installation of our product, including the smart light bulbs, as well as maintain a 24-hour helpline in case anything happens to go wrong. Upon receiving feedback from our initial users, we can then make improvements and externally update the software with any necessary bug fixes. Our successful invisible light switch can then be released to the rest of the world, providing a cost-efficient way of preserving energy to households globally. Before this, we will need to make sure our design is accessible and affordable to the different situations our buyers are living in. Energy consumption could further be reduced by installing our sensors to the doorways of individual rooms, so that the lights are only on when someone needs them to be. Looking ahead, we would also like to integrate a home security system using the pre-existing facial recognition software. This would appeal to a greater market, encouraging safe and sustainable technology in all households.
The invisible light switch aims to eliminate unnecessary power use in households such as the incidents at the home of the writer's colleague. Targeting families with a blind individual are designed addresses the need for an efficient yet simple system to automatically turn off the lights when they aren't needed using computer vision technology. For now, our doorway cameras can intelligently...
Perfect. Your time is now concluded. Thank you so much.
Yeah.
Thank you.
Right. Yeah, we're done anyway. Okay.
Beautiful.
Anyone else want to jump in before me?
Yeah, I've got a quick question, Rob. So does the user get any cues as to what's going on if you're entirely... if you have no sight, do you know when the lights are being turned on and off? Does it let you know?
We haven't particularly designed any feature to let them know, but that is definitely something we can consider as well. Like we can certainly add it into the design if we desperately need it. But on a whole, we don't really see the need for it because the lights will only turn off whenever only the blind person's inside the house or if no one is inside the house. So the system only triggers when no one needs the lights anymore. Right? Sorry?
If the system's failed, how does the user know?
So I was thinking the user wouldn't really need to know. It's more of like just something that happens in the background. So just leave it out of sight, out of mind, basically.
If the light is stuck on and has been for a year, the user doesn't need to know that.
No, that's what this is actually trying to rectify.
But
This is trying. So it's like if it's only the user inside the house, then.
I'm saying if your system fails, your user won't know.
If the system fails.
Yes. So having done a bunch of home...
fails, Don. What are you talking about?
Having done a bunch of home automation and done the home automation with people nearby who are in this call, who get very confused by home automation and the switching systems involved, I can tell you that the fail condition Don is talking about is very common because the infrastructure out there doesn't do a very good job of conveying state information in practicality, even though the protocols say they can. So guys, with this, I think you need to more carefully look at whether you have a feature or a product. And I encourage you to think that you might have a product here, but you need to specifically look at who your target market is, because it isn't just people who are blind. You're basically telling me that it's people who live alone and have visitors who are blind, and that is a significant reduction in potential market for you. So I think you need a better handle on who your target market actually is. Greg.
Yeah, I can see this product being much broader used in the sense of it's sort of an intelligent monitoring system. If, for example, changing heating and cooling to reduce heating use, I don't really like heating. My spouse wants a warm room. It only heats the room where she is. That you can use these in sorts of lots of ways to squeeze efficiency out of the system.
Yeah, and the other thing is you got to remember that blind people are just normal people too, which means that you need to make a cost-benefit argument around the value of your product and impacting the cost of an Australian electricity bill, which is typically high. Yes, there's a bunch of solutions in this space for power monitoring, smart switching, etc. So your target market is probably quite narrow. I encourage you to think, as Greg's suggesting, that there might be broader opportunities around smart sensing in the home and doing something intelligent about that. But if you do want to focus on the blind market, you've got to really be careful to think about, these people, are just folks. So if this thing costs $400, it's not going to sell. If the solution costs $20, well, you might be in play. So you've got to look at the other power monitoring solutions and decide the cost-benefit analysis of your potential target market.
Yeah, so we are going to introduce our projects called the Money Toolbox, and just one second. And there's available solutions for nodes and for nodes value identifications for the disabled people. And we're going to the next slide. And Vivian will trying to introduce for you guys.
So what does this project does? This device is aimed to identify different nodes by their face values and output the nodes value to users either by sound or vibration. This device will be mounted inside the brim of a specially designed base cap with the camera facing directly down, which ensures the best angle to view what is being held in the user's hand. Problem identifications. So for disabled persons suffering from visual impairment, there are several ways to identify and distinguish the object, to approximate the object size, to feel and distinguish the feature of the object, or by other senses such as smell or sound. Therefore, identifying the values of the node is extremely difficult task to do due to similar size of the nodes, which is exactly the same size in America, and lack of tactile features, which is most of Australian nodes and all American nodes. All nodes within the same country have similar textures. So we come up with initial market research. Currently, there are only few products that are fulfilled with the same task. The first one is lens comparator. It is cheap, but requires experience to operate, and it is hard to get the result quickly. And it also requires nodes to have different lenses. And the other product is called iBill, and it is cheap and compact, but it is hard to use, which needs to insert the bill into the slicer. Other possible solutions for disabled people suffering from visual impairment is they could use coins only, or they could pre-organizing all nodes and fold them differently according to different face values. It is quicker to identify what they need, but the disadvantage for this kind of solution is that they need to, it is nearly impossible to do it without helping from others, and it is unable to do for countries using plastic nodes.
Then we're trying to introduce the technical details. Sorry, see here. Just 1 second. One of from our group wasn't in. One of the member from our group wasn't in here. Maybe I was trying to introduce the technical detail then. So just 1 second. So in this case, we are going to have the age detections using the candies and going to the counter, and then we're trying to find out the ages and then trying to detect it. And in this case, when we're doing the filters, filter counters, I initially got so many noise, and then we're trying to improve it. So we're using the counting counters to make the filters, and then trying to crop it, crop the nodes. And since they are trying to, and if there's too much things on the table, they were trying to, and they will to identify things on the table, so it's gonna get a bit noise. And other than that, if the table is clean, they are able to to identify the nodes in the regions, and then we compare the to find out what's the colors in the regions and what's the percentage of the color occupied, like the $10 nodes. If the color of the blue color the blue color is more than let's say in these regions the blue color was more than 30% or 50%, we identify that was a $10 nodes, and send us $20 node and $50 nodes. And that's the color detection region. So we have it. So we identified the blue one is $10, and then red, we determined the blue one is $10, and red one $20, and yellow one's $50. And we have to use the Photoshops to identify each color's regions, and then put in the code we wrote, and then they were introduced as well. So I'll show you guys in the videos. So on the bottom regions, the terminal will shows the nodes which is and identify what node is it. So that's $10 nodes, and it will shows $10 on the bottom. And we get rid of the $10 nodes and put in $20 nodes, and the $20 nodes will come up. Oh, just 1 second. And we're putting the $20 nodes, so the $20 will come up. And when we're putting the $50 nodes, and the $50, it will identify that as a $50 nodes. And it still have a little bit noise, but it works not really bad, I think. And then we have a further improvements, like we're trying to do the machine learning, like says, it will able to crop the nodes and crop the identify what's the number strides on the nodes. And that's what we did, but we're still working on it. It doesn't really work at the moment. Yep. And we have further improvements. Oh, sorry. Oh, yeah. And we have further improvements like the wearable products. So we can like to put these devices on the specified design the like base hab. And like this, we're trying to put the cameras under the heads, and then that will be probably be one of the products used for the disabled person. Thank you for watching. Thank you for listening. That was a bit rushed. Sorry about that.
All good. I'll jump in again. Yeah, so I think you guys need to ask what other solutions are the blind using to solve this problem. I think you need to do some more basic market research as well, because Australia is actually the world leader in tactile note technology for the blind, which was pioneered by Blind Citizens Australia, Emo-Buddy. So this is largely already a solved problem in Australia, directly built into the technology of the notes, unless you've got a good argument that it's ineffective, and that would be interesting. Other things to note is the value trade-off for the product, living with the product itself and the value it delivers. So for instance, having to wear a baseball cap always in case you just might need to handle notes is a pretty edge case, and there's a big usability trade-off. Could this be built into a smartphone as an app? And if that's the case, you also need to concede that there are other technologies out there that already do this. Microsoft actually produces some technology for the blind that does this. Orcam actually has this as a feature built into their smart glasses. So this has been done before. That said, I really like the technical execution, but I should quiet down my commentary on that and leave that to Donna Viorella.
Yeah, thank
Probably
you.
the color is not the most adequate solution for that. So I appreciate that you start thinking in learning techniques. Only vision will be probably a little bit hard to actually identify whether the bill or not is authentic or not. So
yeah,
maybe you can think of a touch sensor.
So I'd maybe just add, putting a sensor downward facing on a baseball cap is a pretty cool idea. I've only seen it a few times before, and I'd encourage you to think of other usage scenarios. So identifying bills, as Rob says, is probably pretty well addressed with tactile notes, but what else could we do with that? Having that view of the world seems like a really useful thing. So I'd encourage you to broaden your scope.
Yeah, I would just echo that while I'm here. People are thinking a lot about holding cameras around, which doesn't work as a form factor. It's an interesting form factor, but when you were talking about alternate solutions, you're talking about other note readers as opposed to completely different solutions, like tap and pay. We were doing some work with spinal cord injuries, thinking they need to find things and sticking tiles and things. They go like, no, it's such a big deal for us. We just don't have that problem. So it's always important to think about how people are always already addressing this, but like the way you're thinking about form factor and technical execution.
Okay. Good afternoon, everyone. I am Ricky. I'm part of the team Why Can't I Be Elon Without Studying? And we are here to present to you our project Vision Impaired. I'm joined by my other colleagues, Daniel, Rithik, and also Tranks. Okay. Ooh, why is that not clicking? Okay, before we begin our project, I would like to ask our judges to see if they could match the socks here. Just a nod would be satisfactory. Okay, thank you guys. What about now? Can you pair these ones? A little bit more difficult. Yeah, a bit if. Okay, last one. Let's try this. Yeah, probably definitely not. You'd be superhuman if you could. Okay. So the problems we're addressing today is to do with blindness as well as color blindness. And I think in our lives, we take so much for granted. Simple things in life become extremely, extremely daunting tasks for visually impaired people. Things such as shopping, things like withdrawing money from ATM, folding clothes, and matching socks. And we're going to deal with this little niche area of matching socks today. According to WeCapable.com, the most valuable thing for a disabled person is gaining independence. A blind person can lead an independent life with some specifically designed adaptive things for them. And it's these little things that make huge differences in their life. They rather do things slowly by themselves than get other people to help. Furthermore, another thing that people who are visually impaired or disabled don't like to be categorized as the other, a different type of person to the average person. And I think wearing not matching socks might be a little bit of a flag saying, hey, I might not be the same. And also, furthermore, we're going with people that are colorblind. I have a friend who is completely black and white colorblind and often rocks up wearing different colored socks or not matching shirts and pants. And he is quite upset when someone would tell him that he's this. As you can see here, as good looking as I am, it just doesn't look right when the socks are the wrong way around. I'm not applying for next season's Bachelor. Okay, Daniel, take us away with our target market. Daniel, I think you're on mute. Okay.
Sorry about that. So the target market for these two groups are going to be totally blind people who can't see anything, and our product can display to them 2 items and tell them with an audible or haptic feedback whether it is a pair or not. And they would have to cycle through independently these 2 items to get the pairs. Whereas if you're just visually impaired or of low vision or colorblind, we've developed a visual system that allows us to display in bold text which are pairs and if there's a pair or not. Next one. So right now, as you can see on the slides and on this camera, we have our vision impaired prototype system here, which right now is just a Pi setting with a light down. But our conceptual design would be to have a stationary system in someone's house, probably in the laundry, where they can have memorize where its position is and have stable lighting and systems and allow them to easily sort. Right. We'll quickly go to our live demo. So right now set up for us here, we have 2 pairs of socks in our test area. If my lovely assistant Train could press the button to begin, you'll see on this screen that I'm shadowing, sorry, that if we press B, we get audible chime for 4 socks and 2 matches, and we get this picture to pop up saying that these are pairs. If I was to remove one of these socks like that and press again, we would only find 1 pair. If I were to remove a black sock from that image and press again, no, we would get an auditory signal saying that there isn't a pair and a little meme because we're having a bit of fun. And if I were to remove 1 more, We would also get another system saying that we have no pair available, and it's an alone sock, and it's an error. And another mean because we're having a bit more fun. Our system is audibly able to tell people whether it's a sock or not. And doing that, we can tell people who are fully blind as well as visually impaired or colorblind. On the screen now is also some examples in previous testing. And I'll hand it back over to Ricky to continue on from here.
Awesome, thanks, Daniel. Yep, so as you can see on the screen, there's a bunch of different variations with 2 pairs, 1 pair, and single socks, and etc. Okay, moving on though, there are some current competition, but nothing of this nature. There's these bands in the top right corner which can pair socks, but in the wash, they're not that practical, and you don't want to have smelly feet. Further on, there are Braille printed clothing, which is much more expensive than normal clothing. As you can see, those socks are $58, including shipping. And also they don't, blind people and people who are visually impaired don't want to be singled out as different, and they are quite screamingly different socks. Next up, there is a $16,000 robot in Japan that can fold clothes for you. It takes 5 hours, but it doesn't even do socks, and it is in US dollars, so even more expensive. And our product will hopefully be approximately like $150. That's including a profit margin, and it also has the potential for NDIS funding from the government because it is a beneficial thing for people who are visually impaired and disabled. Further applications of our project, as we only had 2 days, we couldn't make it as big and expansive as we want, but it could work for shoes. As you can see, we did in the top right corner a pair of shoes that it worked for. It could also work for banknotes because of the different colors, can detect whether it's worth $5, $10. Could organize other household items like cutlery, which I'm sure blind people would find extremely helpful because I don't know how they would personally do that. Otherwise, aside from feeling it, and you don't want to stab yourself with a knife. And finally, in future, what would be really cool is if instead of the audio stimulus, we could develop a robotic claw that can actually pair the socks together and do the work for them. And yeah, that's all we have to present. Ready for question time if you guys are.
7 minutes on the dot, well done.
Yeah.
Maybe really quickly before Rob goes, I just wanted to follow up on your $150 price point. I wonder, do you have an estimate of the cost of your bill of materials? How much are the parts to build one?
So in that costing, we were estimating to have our, just running on the system it's running right now with a Raspberry Pi. We know that we had a look around, that's about the main part of the cost, which is $70 to $80. If we buy in bulk, that would come down a little bit. If we were also to have the plain system, which is just a white bed and 2 lights in the corner, that we estimate that would be around $20 to $30 to build that. And then have the disabled access button, which could be something that the user adds themselves with the disabled access buttons that they sell aftermarket, or we can provide one as well.
Just a bit of feedback on that. A lot of consumer products, the ratio is about 10 to 1 for the costing of the parts to the cost on the shelf. So
Yep.
it's like your profit margin is a little bit, it's off there. So
Yeah.
you want to give your price point a bit more thought.
Yep.
Okay, thank you.
Thank you.
Yeah, I'll jump in. So it's going to sound similar. So yeah, make sure you're solving a high value problem. So I see great marketing here. I see a light attitude to the problem, which is great, and that's laudable. It's actually real positive in this space. To actually have a laugh and have something fun, that's cool. And if the price point's right, you can absolutely pull that off. So the bit that I think you guys should spend more time on is how would a blind person solve this without your technology? To walk through the steps of solving this problem yourself, blindfolded to start with. So I mentioned a few things in a quick thought experiment. Number one, a blind person can tell whether they're holding a sock or not. Absolutely. Okay. They're not going to mistake it for a shirt or something else. They know they're going to be holding a sock. So that comes down to pairing of those socks, which is fair enough. You guys have a solution to do that. Now, the issue that you've got here is that you're forcing the person to work as a robot to do a whole bunch of manual sorting to actually keep putting different items under the viewer area in order to pick out what's what. Now, what I do like about what you've done is to figure out, different colors, pairings, etc. That's pretty awesome. But there still needs to be a bit more thought about how exactly this works. I'm sure you guys can figure it out. But make sure you're selling a product, not just a feature, because this could fall into the feature trap. Thanks.
So I assume the technical problems you have here is the uniform lighting, right? So
yeah, so
that's why it's so big and bulky, your system.
So yeah, right now.
Did you actually have a thought on some solutions to that?
Yeah, one thing that we had in our discussions was that when a blind person relies on a lot of hard-coded memory when they guide themselves around their house. So if we can introduce a system, probably about something that can go on a benchtop in their laundry area, if they can have that system in there, they can memorize where it is, so they don't have to have something that they're holding, which we thought of at first, but that's something they're not going to be able to use easily. After that, we think it'd be easy enough if you have overhead cabinets.
I'm referring mostly from the image processing point of view.
Yeah. The thing, like if we have like the overhead cabinets, we would have a ring light around the camera itself to have unidirectional light from the camera's point of view. So it can eliminate a lot of the shadows that it would face and can throw off image detection there.
Good thinking.